processes the video. Is that doesn't happen right away. So you have to wait probably a couple of hours. Okay, so if you checked right away or an hour after yesterday's class, probably you didn't see anything. But as soon as I received the video, I uploaded and there it is, no problem. Okay, so it's just a matter of waiting probably a couple of hours. Okay, but yeah, there we have the video and the notes. But of course, anytime you notice that it's not, if there's something missing, of course, please let me know. Thank you anyway. Any other question about last class, about the rules for this course? Also remember that I asked you to start taking a look to this material, to this video about value at risk, and then to read this article. Okay, so I would assume that you will have enough time from last class to tomorrow. I think tomorrow we can spend some time discussing ideas or any questions you may have about this value at risk video and article. Okay. Okay. Any other questions? Okay. Okay. If there are no questions, let's continue. Remember that we gave a general introduction to the course last class, especially in terms of the importance of accounting. Let me open the notes. Okay, we spent some time, right? Sorry. We discussed about the important subjects for this course. Of course, all the things you have learned so far, but especially accounting, and we discussed what's in the balance sheet for an insurance company or for a bank in general terms, and also about probability. We made emphasis on as mixed type random variables that they are going to be important in this course, the decomposition theorem, and how to calculate the expected value of a mixed type random variable in terms of its distribution function, because mixed type random variables do not have neither a PMF nor a PDF, right? Probability mass function, PDF, probability density function. So if Z is a mixed type random variable, you have to make all the calculations through its distribution function. And also about probability, sorry, let me change the size. We said that this is going to be very useful in this course to understand the difference between the conditional expectation as a random variable and the conditional expectation as a function of a specific value of the conditional variable. And also these two formulas, the expected value of this conditional expectation random variable and the variance in terms of this, okay? So that was basically the general introduction to this first topic that we mentioned, that is individual and collective risk models. Okay, so that was item, let me go back. That was, I believe, yes, 1.1, right? 1.1, that was introduction of this topic. So I will start with topic 1.2, which is going to be the individual risk model. So we are going to learn two types of models, individual risk models, and then we will learn about collective risk models, okay? So let me go to a Blackboard, just a moment. So I hope you are watching my Blackboard. If not, let me know. I haven't written anything, just a moment. Yes, let's see. Okay, yeah. Sorry. Just a moment. Okay. So 1.2 individual risk model. Okay. So this is the ideal approach for anything, because we are going to have a specific model for each source of uncertainty. Okay, so this is the simplest way, the simplest approach. In fact, is the best one, in terms that it has all the details of each source of uncertainty, but in practice, with huge insurance portfolios, this could be not very practical to implement. And in those cases, you have to go to another kind of models, which are the collective risk models. But whenever it is possible, it's better to have an individual risk model. So under this approach, we will have for each source or for each individual insurance contract, we will have a random variable. Okay, so for each, let me change the color here. So each insurance contract is represented by a random variable. Okay, remember that I will use this abbreviation to refer to a random variable. Okay, so we said that risk theory was first developed as necessity for the insurance sector, but also these ideas can be applied to the banking sector. So in some cases, instead of thinking about an insurance contract, you may think about a loan. Okay, so but we will be talking mostly in terms of insurance products. So each insurance contract is going to be modeled by a random variable. Okay, and the purpose is to aggregate all the random variables from a certain portfolio. So we have to consider that an insurance company has many clients, and all those clients are grouped into what is known as a portfolio of insurance contract. Okay, so we may use the notation, a very simple notation, for a portfolio of n insurance contracts, we can just use numbers 1 up to n. Okay, I mean, let's not make things complicated. Okay, so insurance companies group all their clients by products, and then they have a portfolio of all the life insurance contracts. They have another big portfolio of all the automobile insurance contracts, and so on. Okay, so the portfolios are just groups of insurance contracts from the same product usually. Of course, sometimes insurance companies may group certain contracts, not specifically because of the product, but because they have something in common. For example, when we talk about group insurance, let's say a product that was designed or sold to a specific company, right? So a company bought insurance for all their employees, for example. This is very common, okay? So then they may have a portfolio of all the insurance contracts that are employees of a certain company who hired the insurance company. Okay, so there are many different reasons or criteria that we may use to have a group of insurance contracts. Okay, so that's what we are going to call a portfolio of insurance contracts. So if we speak in terms of a random variable, let's say random variable xj, okay, and this random variable xj is going to represent the claim amount. Okay, so also get used to the vocabulary. In English, claim amount. In Spanish, suma asegurada. Okay, I mean, the literal translation would be la cantidad reclamable, but in Spanish it's suma asegurada. In English, it's the claim amount. Okay, so I'm sorry, I did it wrong. El monto de la reclamación. This is monto reclamación. Sorry, I said suma asegurada. No. Monto de reclamación in Spanish, claim amount from contract J. Okay, where J is one of these insurance contracts. During the policy or coverage, also coverage period. Okay, because you know that usually an insurance contract is for a certain period of time, could be 1 year, 5 years. In some cases, it's for life, but usually they have a term of a period or a coverage period, right? So, if let's say for life insurance, right, we are covering for 1 year. If the person dies, we pay the insured amount. That one is suma asegurada, the insured amount. Okay, in case the person dies. If the person survives, the claim amount is equal to 0. Okay, so that would be an example. So we are modeling how much money is being claimed by each contract. We expect from most contracts to be 0, right? Because we sell coverage against events that have a very low probability, but that in case they happen, they may have a big impact on the client, right? So, but the idea is that from all the insurance contracts in the portfolio, just a few of them will have a positive claim amount, right? Most of them, their claim amount is going to be 0. Okay, so for sure, when nothing happens, 0, it's always a possibility that nothing happened to the client, so there is no claim or a claim amount equal to 0. So 0 has to be always an element of the range of random variable xj, right? Remember, the range of a random variable is the set of possible values for that random variable. Okay, so 0 has to be always a possible value for a claim amount, because it represents the case where there was no claim from the client. Nothing covered by the insurance contract happened to the client, so there is no claim or 0 claim. So in this case, we have that the point probability of 0 has to be positive. Okay? So with just this observation, what type of random variable is xj? Or what can you say about the type of random variable xj is? Anyone? If that has to happen, what kind of random variable is xj?
Bernoulli?
Not necessarily.
Not a continuous one?
That's right. The only thing we can say is that it's not going to be continuous, right? Because if xj is a continuous random variable, all point probabilities are equal to 0, right? So since there is always a positive probability that there is no claim from the client, and in fact, this probability is usually very high, very close to 1, okay? So this is enough to say, I don't know what type of random variable xj is, but for sure, it's not a continuous random variable, I mean, okay? So continuous random variable is discarded for xj, and in general for any kind of insurance model, right? It's a shame, right, that we have to forget. We spend so much time now learning about continuous random variables, and for insurance, that is supposed to be our special area as actuaries, we cannot use continuous random variables for the claim amount. But that's the thing, that the nature of insurance contracts is that there is a high probability that there will be no claim, right? We are just covering for a small probability events, okay? Small probability events, okay? So continuous random variable discarded. Why is not discrete necessarily? Because somebody said Bernoulli, okay, probably Bernoulli, but it may be or it may not be. In which case you will have something like a Bernoulli random variable, and in which case not necessarily discrete random variable. Anyone? Because it depends on the type of insurance that we are considering, right? If it's just life insurance with a fixed insure amount, so there are only two possibilities, like a Bernoulli random variable, right? The person survives, no payment, zero. In case the person dies, we pay the insure amount, okay? So it's a Bernoulli multiplied by an insure amount. So in that case, yes, XJ would be a Bernoulli random variable. But what if it's automobile insurance, okay? That covers for both accidents or theft, right? So if nothing happens to the car during the coverage period, again, zero claims, okay? So again, zero has to be a value with positive probability. But in case there's an accident, how much we're gonna pay? We don't know. It will depend on each case. There are different ways that a car can get damaged, and the price for repairs or replacement, I mean, it can be any positive real number. So in that case, it will be a mixed type random variable. Do you see how fast I told you last class? We are going to find very often that a mixed type random variable will be the type of random variable we need, okay? But that will depend on the insurance product we are considering, okay? But for any type of insurance product, zero claim is always a possibility with positive probability, okay? Has to be part of the range. And also, since we are talking about claim amounts, there is no room for negative values for the random variables, right? So we have that the probability of xj being greater or equal than 0 equals to 1, okay? So this is important to consider because we know, or you already know, have learned many probabilistic models for random variables who have which have a support on the whole real line, and some models that have a support only on the positive real line, right? For example, the normal random variable has a support in the whole real line, right? It takes positive or negative values. So this is not something appropriate for this kind of random variables, right? But for example, the gamma distribution or the log normal distribution or the Pareto distributions, all of them have a support on the positive real line. So these are models that might be considered or that satisfy this condition because xj is a non-negative random variable. I don't say a positive random variable, I say non-negative because 0 has always certain probability. Okay, so 0 is always a mass point for random variables used for claim amounts in insurance. Right? Another important feature about this kind of random variables is the fact that we have usually another mass point, which is the probability that xj equals a certain amount that I'm going to call tau is also positive. But what is tau? Tau is what is known as a policy limit or maximum insured amount. Okay? All insurance contracts have, well, usually all insurance contracts have a maximum insured amount. In case of life insurance, it's very clear. It's usually, if you die, we pay a certain amount. If you survive, we pay nothing. Okay? So the policy limit in that case is the insured amount. But let's think about major medical insurance. Right? So in case you have a sickness or have an accident that is covered by your major medical policy, major medical, gastos médicos mayores in Spanish. So in case you have an event that is covered by your major medical policy, then there is a limit because we don't know how much money you are going to spend for being in the hospital, having a surgery, paying the doctors and everything, okay? But the policy usually establishes a policy limit, and they will say, okay, we can pay up to 10 million pesos, okay? So as soon as all your claims from your accident or from your sickness doesn't surpass the policy limit, the insurance company is going to pay. Otherwise, if you get to the policy limit, the insurance company stops paying and you have to continue paying somehow. Okay, so this is the policy limit. So that may happen. I mean, even if the claim amount is above tau, we say we are just paying tau. That's the reason why the maximum insurance amount, which is represented by tau, is also a probability mass point. Okay, so we have usually at least 2 probability mass points for claims random variables: 0 and tau, which is the policy limit or maximum insured amount. Okay, so as we already said, since 0 and tau are probability mass points, xj is either a discrete or a mixed type random variable, or mixed type random variable, right? So continuous random variables discarded. Okay? Now, this is a big thing to say. I mean, it's very easy to say, okay, I will have n random variables and each one of those random variables will be linked to a special insurance contract. I mean, each XJ represents claims from a different client, okay? So, okay, we will have a lot of random variables considering a portfolio of insurance contracts, and the insurance company has to take care of all the clients. So that's the reason why they have to add up all the claims that may come out from an insurance portfolio. Okay, so we will need now a random variable that adds all the individual claims to know or to have a model for the total claims from an insurance portfolio. Okay, so let's define now a random variable. We're going to call it S from sum, and this will represent the total claims amount, the total claims amount to be paid by the insurer. I'm sorry by my writing, to be paid by the insurer from, it's terrible my writing, sorry, by the insurer from a given portfolio during a certain coverage period. Okay? So S is just the sum of all the individual claims. As simple as that. Okay? So now you already know how to, if you have, first of all, the first task, of course, is how do I choose a probability model for each insurance contract? Okay? Because each client is different, right? Even if we are talking about the same product, life insurance or car insurance or major medical insurance, each client represents a different risk, right? Different age. I mean, variables like age, sex, job, right? Job type, the place the person lives, the place the person works. I mean, there are many factors to consider to build a model for each client. So in principle, this sum is not going to be a sum of identically distributed random variables, right? As we usually do. We already know how to deal with the sum of independent and identically distributed random variables, right? But right now, if each client is different, for sure the model is going to be different for each random variable. So these random variables are not going to be identically distributed. Or probably we can use the same probability model, but the parameters that we have to fit for each client are going to be different depending on age, sex, job, salary, and many other factors, right? So that's what I mean that these random variables are not going to be identically distributed. And if they are going to be independent or not, well, that's a question that we have to ask every time. I mean, if it's reasonable to assume that these random variables are independent or not. Well, how do you think we can decide for a certain portfolio of insurance contracts if it's reasonable or not to consider the random variables to be independent? Why we love independence? Because calculations become easier, right? And that's okay. The problem is that it's good news when we have, or when we can assume that the random variables involved are independent, calculations become a lot easier, right? But what if not? So if we have, let's say, a portfolio of life insurance contracts, imagine certain insurance company in Mexico that sells life insurance to different people. They have different clients. In that case, would you consider that all the clients are independent from each other as random variables?
No, because maybe they could be relatives.
Yeah, I mean, the answer is it depends, right? It depends on, well, who are they? I mean, if this portfolio of insurance contracts was sold to different people that do not know each other, right? I mean, just random people that work in different places, live in different places. In that case, it would be reasonable to consider an independence assumption and take advantage of it. But for example, imagine that a certain insurance company sold all the life insurance contracts for the teachers at FESACatlan. I mean, it's not a matter of being relatives. The thing is that all the teachers at Acatlan have in common that they work in the same place, right? So, in a specific event that takes place in Acatlan, right? For example, let's think about an earthquake, and strange earthquake that strikes Naucalpan and that hits very hard the area of Zacatlan. And so many buildings come down and many teachers die at the same time. So there is dependence, right? Because all the teachers work in the same place and are at the same place approximately at the same time, right? So in that case, it would not be reasonable to assume independence. So the fact is that the random variables that represent claims from an insurance portfolio are or are not independent depends on the client's profile. So that is something that has to be analyzed in each particular case, okay? So we don't have guarantee that the XA's random variables are independent, but usually they are not going to be identically distributed. So this is going to be a problem, okay? Because you learn very nice techniques that when you have n independent and identically distributed random variables, is quite easy to obtain the probability distribution from random variable S, right? But if you don't have identically distributed or independence, this is going to be a more complicated task, but we have to do it, okay? So the thing is, why do we want this? I'm going to number these ideas. This is going to be number 1, because this is the total claims. Sorry. So total claims amount. So we need this because once we have a model, we need a model for this, okay? So we will discuss how to do it, but you already know some ideas or some techniques to do it, because with the model, then we can calculate things like the expected value of S or the median of S. I mean, I would use this notation for the median, which is not very common, right? So we want to calculate the expected value of S and things like the probability of S being greater than certain amount, S0, or we want to calculate value at risk, right? Remember, video and article that you're supposed to review, right? And the value at risk in terms of probability is just the quantile function, right? The inverse evaluated at alpha, for alpha between 0 and 1. And why are these amounts important? Okay, let's go back to accounting, right? I told you, you have to love accounting, especially the balance sheet, because we are going to be discussing all the time all these calculations that are important. Where do they impact the balance sheet of an insurance company? Well, let's draw a balance sheet. Here. Yeah. Okay. Well, I'm not going to write the full name. You already know in English. Assets, liabilities, and capital. Okay? So, according to the ideas that we discussed last class, I mean, the company, there is no way the company can know with total certainty what will be the total claims amount that they are going to face during the year, right? So S represents the total claims that the insurance company is going to pay during the year. They don't know how much they are going to pay because it's a random variable. It depends on many things, right? But at least they need a point estimation. So either the expected value or the median are point estimations of S, right? So we don't know what's going to be the final value, but a point estimation of S is could be something like the expected value of S or the median of S. Okay. So these two amounts, where would you put these amounts in the balance sheet? Anyone?
Liabilities?
That's right. We said that last class, right? We said, okay, we don't know the final liabilities for the insurance company. We don't know what are they going to be, but we have a point estimate of the liabilities, and that goes here, right? So let's write it down here. So in the liabilities, we have something that we call, let me use the correct name, Bell of S. Bell is for best estimate of liabilities. Okay? And yes, your best estimate could be the expected value of S, the median, or some other that you can justify, right? It doesn't have to be one of those, okay? It's a common way to estimate, okay? But it's the best estimate of liabilities. So it's saying, okay, we are aware that we cannot know in advance the total amount that is going to be paid by the insurance company, but at least you should have some idea about it, right? And that approximation of the total claims has to be here, right? Okay, so according to the basic accounting rules, the liabilities always have a counterpart in the assets, right? So we need an amount of money in the assets or something in the assets that covers for that liability. What is this in the assets? What do you think it is? Anyone? You will need money, okay? Because if you're saying, okay, our best estimate of the total claims that we will have to pay during the year is this amount, okay? Make sure that you have that amount of money here ready to pay what you are estimating that you're going to pay, right? So here you will have investments. But not any kind of investment. Has to be certain type of investments that can be changed to money ready to be paid to all the clients that file a claim. Okay, so this money, where does it come from? What do you think?
I think you said that last class they come from the premium.
That's right, the premiums. So, I mean, this is the general idea. Of course, there are many details that we will discuss later, but in general terms, the total premiums that need to be collected for an insurance portfolio should be at least equal to the best estimate of the liabilities, because we are saying my estimation of what we're going to be paying in claims is this amount. Okay, I need money to pay this, and this money is going to come from the premiums, right? So that's why it's very important for us to have a model for S, right? Have a good model, because we're going to use it to make a point estimation, which is called the best estimate of liability. It goes here, right? It goes here. And what about this one? I don't know if you already watched the video and read the article, but at least you should know what this is, right? This is the quantile function, or the inverse of the distribution function of S of level alpha. What does it mean? What does it mean? I mean, if we call the alpha this value of risk, the inverse, then I evaluate in f of s in both sides. So that means that f of s evaluated at z alpha equals alpha, right? And this is the probability that s is less or equal than z alpha, right? So, why is this so important? And usually, just to have an idea, alpha is very high, very close to 1, 99.5%. Remember that the median, for example, is the 0.5 bar, right? Because it accumulates 50% of the probability. So that means that the median is smaller than the bar of level 0.995. So this amount is more to the right. I mean, just for illustration purposes, because we already said that S is not a continuous random variable, right? Because if all the x's are not continuous random variables, well, the sum is not going to be a continuous random variable, okay? But just for illustration purposes. Imagine there is a density. Okay? And probably the median is here. But the bar is going to be to the right, right? Because this means that all the area from 0 up to here is 0.995, right? So what we have here is that we're saying our point estimate is the median or the expected value, whatever, right? But this density is saying, okay, but we have variability around this point estimate, right? At the end of the year, how much will we pay by the insurance company? Could be something above this point estimate or could be below, right? Because there is variability. So when we talk about the value of risk of a high level, we are saying that we expect with a high probability, 99.5% probability, that in a worst case, this would be the total paid amount. Okay, there's still some probability that it can be even higher, right? But we're saying that with probability 0.995, the total claims will not be above this amount. So if we already have this amount here, represented here, okay, these investments are going to be enough to pay this amount, right? So if at the end of the year, the reported value by S is equal to the point estimate or below, no problem. All this money is going to be enough to pay everything. The problem is if at the end of the year, the insurance company has to pay more than the point estimate. That may happen, right? That is variability. So if the variability is above the point estimate, we're going to get more money to pay all the claims. This money is not going to be enough. Where is it going to come from? We mentioned that yesterday. Anyone?
We could take money from the capital.
That's right. That's right. That's what the capital has to be there in case it's needed. Okay. So since we already have money for this amount, and we are saying, okay, in a worst case scenario with probability 995, okay, we need this extra money, right? So this difference between the valued risk and the point estimate we use for the liabilities, that could be the expected value or the median or something else. This is a very important concept called solvency capital requirement. Okay? Solvency capital requirement. Okay? So part of the capital is going to be labeled as solvency capital requirement. Not all the capital, but part of it is labeled solvency capital requirement of S. So the company owners are free to have more capital or an amount of capital that is above the solvency capital requirement of S. That's their choice. But what cannot happen is to have less money than that. So insurance regulators from the government are checking all the time that each insurance company makes sure, and they can prove that they have at least the solvency capital requirement in the capital. Okay? And of course, this capital needs a counterpart here, right? It has a counterpart in the assets. And these have to be also investments. Okay? But these two types of investments, also the money that is backing the bill and the money that is backing the solvency capital requirement, have to be low risk investments with high liquidity. Liquidez en español, right? High liquidity. What does it mean to have high liquidity in terms of investments? Anyone? An example of high liquidity investments or low liquidity. What's the difference between high and low liquidity? Have you heard about the term? Spanish is liquidez.
With low liquidity, we can access the money at a faster time than with the. Well, we can access the money with a faster time.
That's right. Examples? An example? Anyone?
Maybe bonuses.
That's right. Government bonds, for example. Treasury bills, what we call CETES, bondes, right? Usually government debt, short-term debt, is low risk investments, and they are very easy to sell to the market and get the money, right? So while the money is not needed, has to be invested. But since this money has to be ready, right, to be used to pay for claims, okay? So there are certain rules that are specified by the government regulators of the insurance sector. Who is the government regulator of the insurance sector?
AMIS, right?
No.
Okay.
Okay, but I will mention something about AMIS, okay? Rules set by CNSF, which is the Comisión Nacional de Seguros y Finanzas, right? So the CNSF is the government regulator of all insurance companies, okay? And it depends on the finance ministry, which is the Secretaría de Hacienda. Depends directly from the Secretaría de Hacienda, okay? So this is the government regulator for insurance companies. They set the rules, and they tell the insurance companies what can they do with the money, with investments that is either backing the bail or either backing the solvency capital requirement. Because this money has to be ready to be used to pay for total claims, right? And in case this money is not sufficient, because it may happen, this is just a point estimate, if they run out of this money, then they start using this money. Okay? So what is AMIS? Just for you to know.
Asociación Mexicana de Seguros, ¿no?
Asociación Mexicana de Instituciones de Seguros. This is a private entity, not a government entity, okay? This is a private association of some insurance companies. In fact, it's an association of the most important insurance companies. Not all the insurance companies belong to AMIS. They don't have to. It's completely voluntary. It's for their own convenience. They created this association because instead of leaving each company, insurance company, to deal with the authority to negotiate regulations, rules, and so on. They said it's going to be better if we gather all the insurance companies, gather into an association of insurance companies, because they can join, gather all the best ideas they have, and they, as an association of insurance companies, they can go in a united front to negotiate things with the Comisión Nacional de Seguros y Fianzas. Okay, so yes, AMIS is very important, but it's a private entity. They do not regulate. They propose things, they negotiate things with the government regulators, but the regulator is this one, the Comisión Nacional de Seguros y Fianzas. And they have to supervise all the time insurance companies. And they check many things. But they check especially the bill. They will say, how are you calculating the bill? And you have to convince, of course, with actuarial models, that you have a correct or a good approximation of the bill, right? And then you have to show that you have the investments that are backing this bill, right? You will have also to explain or answer questions about how are you calculating the solvency capital requirement, and then show that you have the investments that are backing the solvency capital requirement, because these two are calculations, probabilistic calculations. So they have to check that these are correctly calculated, and then afterwards go to the accounting area and the finance area and say, okay, show me what are the investments that are covering for the BEL and the solvency capital requirement. And you have to check, they are going to check that those investments are in line with the rules that they have to follow. Okay? Because sometimes insurance companies would like to put some money in riskier, have riskier investments in order to get higher yields on those investments, but they cannot go beyond the rules that are set by the regulator. Okay, so the regulator is all the time checking the balance sheet, the calculations, the investments, and so on. And I'm telling all you this because this is why it's so important, the model for the total claims S. Because for this model, from this model, we are going to calculate the BEL and the solvency capital requirement. And of course, even if you have the correct BEL and the solvency capital requirement, this capital, I mean, the BEL plus the solvency capital requirement doesn't have a 100% probability that it's going to be enough. I mean, that means that insurance companies have enough money to pay all their obligations with a 99.5% probability. It's not for sure. I mean, there is a 0.005 probability that they won't have enough money and that they can go broke. Why do they allow them to do that? Why, instead of asking for a 99.5% probability of having enough money, why they don't ask for 100%? I mean, the probability that an insurance company goes broke with the Mexican rules it's as small as 0.005, but it's not zero. So why do they allow them to do that? Why don't ask them to have enough capital so with probability 1, the insurance company will be able to pay all its obligations with the clients? Why they allow this 0.5%? What do you think? Any idea? Well, think about it. Think about it, because this is very important to understand the insurance business and the bank business, because the situation with the banks is quite similar. They are required to have a point estimate of the loans that they are going to recover, and also a similar thing of the solvency capital requirement, so that they can fulfill their obligations with a 99.5% probability, not 100%. That's why sometimes banks go broke. Why is that? Why does the authorities, why the government allows that for insurance companies and for banks? There is a reason. It is not that they are bad people, right? That they don't care about people. No, it's not that. There is a important reason that I would like you to find out. Okay? But all this was to show you something as simple as this. I mean, the probability that we are going to use for the models is quite simple. You will see. You already know enough probability for what is needed in this course. No problem. Very simple things, but very important. Simple, but very important. So that's why it's very important to make the correct assumptions about each random variable, to make the correct assumptions about their independence or lack of independence, and to obtain a good approximation of the probability model for the total claims random variable. S, because from this model depends that you have a good calculation of the BEL and the solvency capital requirement, and on this depends the premiums that are going to be collected. Many decisions come out of this. Okay, so that's why we have to be very careful about the models. Okay, let's continue. Item 2. The individual policy model. Okay, so let's go contract by contract. We already know that each random variable that represents an insurance contract is going to be either a discrete or, it's terrible, my brain, a discrete or mixed type random variable xj. Okay. Also, we said xj represents total the claims that are coming out of contract number J. The probability that the claims from contract J are between 0, including 0, and tau, which is the policy limit, is going to be equal to 1. Okay, so remember, this is the policy limit. Okay, so that's another assumption for this individual policy model. Also, that the probability of xj being equal to 0 is significantly higher than 0, close to 1. Okay, so this notation here is a kind of a double greater than sign. So let me specify. Means not just greater than, means significantly greater than 0. Okay, so then 0. Okay, which implies that is a lot closer to 1 than to 0. Okay, remember, probability of xj being equal to 0, or that the probability that the claim from an individual contract is going to be 0, is usually going to be very high. Okay, because we are covering for events that have a low probability. In case they happen, they usually have a huge economic impact on the client if they happen. But they have to be a low probability event. Otherwise, it wouldn't be possible to have reasonable prices for the coverage. Okay, so this is part of the assumption for any individual policy model. This is not a particular individual policy model. We're just saying any individual policy model has to satisfy these characteristics. To be the claims random variable, to be discrete or mixed type. That with probability 1, the claim amount is going to be between 0 and a policy limit. That the probability of 0 claim is not just positive, is a probability very close to 1. Okay, and this implies, in turn, of course, with basic probability reasoning, that the probability of xj being greater than 0 is also 1 minus probability of xj being equal to 0. Okay, and also we have for tau is the opposite, right? The probability of the claim from policy j being equal to the policy limit has to be significantly smaller than 1, closer to 0, closer to 0 than to 1. Okay, and just for notation, I'm going to use qj for the probability that xj is positive. Okay, where are we getting this information, this probability? How do we get this probability? This one is called the claims rate. But where do we get this information from?
Maybe from the distinct amounts of the claim that can be done?
Well, think about life insurance, because we are considering any type of insurance, but the easiest example is life insurance, right? So in the case of life insurance, what is the claims rate for life insurance? And it's on purpose that I'm using letter Q, because probably that reminds you about something you know about life insurance. Remember?
Yeah, probably to die. Someone
Uh,
with HJ.
That's right. That would be the probability of death within a year of client J, right? Which depends on the age, right? So we need a mortality table that considers, remember that for mortality tables, we consider at least 3 factors. Age, of course, sex, because the probability of death is higher for male than female, okay? And also, there is a third factor that is very important. Anyone remembers? We consider age, sex, and very
If
important.
the person smoke,
That's right. If it's a smoker or non-smoker person, okay? So, and we have mortality tables that consider those 3 factors. How are those mortality tables built? Where are they? I mean, probably in your courses, they say, okay, use this mortality table to calculate some premiums and so on. Perfect. But where uh, those mortality tables come from? How do we build them? I mean, when they give you a mortality table, okay, somebody made that mortality table. How do they make the mortality tables? Any idea?
I don't know how do they make the table, but I think there is a table in the CNSF.
Yes. And how do you think the CNSF makes that mortality tables? Yes, there is one. They can use let's say the official of the government mortality table. But in what kind of information is that mortality table based?
On deaths?
Whose deaths? Which deaths? Any deaths? All the deaths in the country?
I think they are based on the amount of people that dies from a certain population through time.
Well, that is not exactly the case, because that would be correct if all the Mexican population had insurance, right? Do all Mexicans have insurance?
No,
No.
Of course not.
No.
What kind of people buy insurance? It's an average Mexican? The average Mexican buys insurance?
No.
Of course not, right? It's kind of privileged people, right? People that, after satisfying their basic needs, right? A place to live, food, health. They still have some extra money that they say, okay, let's buy protection. So it's a minority of the population. So I cannot use mortality information from the general open population because that is not representative of the kind of people that buy insurance. It's a minority of the population that buys insurance. I don't remember exactly. I think it's something around 7% of the population that has some type of insurance. So you have to use the information about the mortality experience from that people, from the people that buy insurance, right? Not from the whole population, but only from the people that buy insurance. So since all the insurance companies in Mexico have to report their own statistics from other products to the regulator, to the CNSF, the CNSF can aggregate all the information. And with that information, let's say from all the insurance companies, they can use all that information to build a mortality table. Because it's only with the profile of people that that buy insurance. And why is this so important? If we compare the average probability of death of all Mexicans, and we compare it to the probability of death of those people that buy insurance, which one do you think is higher? The probability of death of the general population or the probability of death of those who buy insurance?
The probability death of who don't buy insurance.
That's right. Why? Why is that? What do you think is that?
Because the people who buy insurance are a privileged population who has better opportunities of take care of herself or something like that.
Yes, that you are completely right. That's the reason why. Because they have a better circumstance. Okay, they have more resources to take care of themselves. They have better access to health services, to healthy food, to many things, right? So it wouldn't be fair to use the mortality experience of the whole population to calculate the premiums of for life insurance, because the premiums will be unfairly high, right? They will be higher than they really need to be. Okay, so yes, with that experience, but do you think it's the same mortality probability from one insurance company to another insurance company? Now we are constrained to the small universe of people that buy insurance in Mexico. So people can buy insurance from different insurance companies. So do you think it's the same mortality experience from one insurance company to another? Because the CNSF aggregates the information of all the insurance companies, right? And they build a mortality table. So that mortality table that is published by the CNSF and and a mortality table that can be used by insurance companies. It's an average of all the insurance companies. But my question is, and if we compare the mortality experience for one insurance company to another, is it the same or not? Or is it approximately the same or not? What do you think?
It depends because it's not the same type of clients in one company another.
That's right. They might be differences, right? Because each company has, even though all the companies have to comply with the official rules, the government's rules, to be that all the insurance companies have to follow. They internally, each company may have different ways of getting their clients, right? So the client's profile from certain insurance company could be quite different from another, right? So yes. So the answer to this question was this claims rate that, for example, in case of life insurance would be the mortality table, is an estimation based on own or market experience, or insurance market experience, let's be specific, or the insurance market experience, right? What does it mean to be based on own experience? When a particular insurance company has been selling for a long time a certain type of insurance product, they can build their own statistics and their own mortality table based only on their clients. So in that case, they may build their own mortality table and they don't have to use the CNSF mortality table. When an insurance company doesn't have enough own experience, then they will have to use the CNSF table, which is the insurance market experience on average, right? So the insurance companies have these two options. But when an insurance company wants to build their own mortality table, they have to justify that they have enough information and they have enough quality information to build their own mortality table. And then they can, if the CNSF is convinced that everything is okay with that information, then that insurance company can use its own insurance experience. Okay, so this information, these probabilities come from statistics from the whole insurance market as a whole, as an average, or based on own experience. Okay, good. Okay. Any questions so far? So these are the basic elements of any individual policy model. This type of random variable for each contract, discrete or mixed type, always between 0 and a policy limit. 0 is always a mass point with a high probability, closer to 1 than to 0. Tau, I mean, to reach the policy limit is the opposite, has a very low probability, but positive, okay? And we need probabilities of positive claims, which is estimated based on experience, own or market experience, okay? Now, how do we estimate the models? Now, from contracts that have filed claims, what does it mean to file a claim? To file a claim is, in Spanish, to hacer una reclamación or presentar una reclamación. Okay, so from contracts that have filed claims in previous years, we may estimate for any x greater than 0 and less equal than tau, a conditional model. Why conditional model? Because it's going to be based on those who had something to claim, right? Because if we have only data from those contracts that file a claim, that has something to claim, it's conditional on the situation, right? Xj being positive, that means that contract number J had something to claim regarding the policy. Okay? So this is the way to represent that there was a claim. Xj being positive is an event. The event that something happened to the client that was covered by the insurance contract. Okay? And by definition of distribution function, this is the probability of xj being less or equal than small x, given that xj has been positive, that there was a claim, okay? And by definition of conditional probability, this is the joint probability of these two events, which is the same as writing that the intersection of these two events is that xj is positive, but at the same time is less or equal than x, divided by the condition, the probability of the conditioning event, right? Which is the probability of xj being positive, right? And remember, this is Pj, right? Pj, remember, was exactly the probability of xj being positive. So Pj is the probability that an event covered by the insurance contract took place, happened. Okay? So this model might be continuous, discrete, or mixed type. Or mixed type. In contrast with f of xj, which cannot be continuous. Why? Why do you think is that? I mean, this last part, I think, is obvious, right? We already said xj cannot be continuous because at least 0 and tau are probability mass points, right? They have positive point probability. So that's the reason why xj cannot be a continuous random variable. But why I'm saying that this condition, this is a non-conditional distribution function. But what I'm saying now is that the conditional distribution of xj, given that xj is positive, this one might be continuous or not. Why we can have continuity here, even though in the non-conditional case, there's no way we can have a continuous random variable model. Why we have this possibility open in this conditional case? Or can you think about an insurance product where this is possible, where the conditional distribution of xj, given xj positive, could be a continuous random variable model?
Maybe because we took off the mass point that we know that it necessarily has to be a mass point. So maybe with that point off, it can be continuous in the range greater than 0.
Yeah, I mean, I agree. When we condition on xj being positive, yes, we are removing the 0 mass point. But what about tau? Still there, right? Tau is not being removed. I mean, that would be possible if there is no policy limit. Does that happen in practice? Not having policy limits?
No.
No.
Not right now. A few years ago, there were insurance products with no policy limit. I know it sounds crazy. In fact, I still personally have a major medical insurance with no policy limit. Why they sold to me a major medical policy with no policy limit? Because there were some crazy actors that designed that kind of product. I mean, my major medical insurance policy says clearly in the part where it says insure amount, it says with no limit. Now it's forbidden. After some time, the Mexican regulator figured out that that was crazy. And that was a very high risk product for insurance companies. So from certain time to present, insurance companies are not allowed anymore to sell insurance policies with no limit. I mean, for me, as soon as I keep paying my insurance policy, they have to keep it that way. But they are not selling anymore. It's not allowed anymore to sell insurance policies with no limit. In that case, it will be possible to be continuous. But since this is not allowed anymore, okay, you're removing, yes, the 0 probability mass point, but there is a policy limit. Okay, so again, still we are dealing either with discrete or mixed type random variables. Okay. So from this equation, we can rearrange this equation, this one, and express that as a product, right? I can now write this probability as a product of this conditional distribution function times Qj, right? So the probability of xj being strictly greater than 0 and less or equal than x is equal to Qj times f of xj given xj being positive. But by definition, remember, this probability can be expressed in terms of the non-conditional distribution function of xj, right? I mean, by basic probability, this is equal to f of xj evaluated in x minus f of xj evaluated in 0, right? But this one is the probability of xj being less or equal than 0. But since xj cannot take negative values, the only possible value for this case is xj being equal to 0, right? Which is 1 minus qj. So I can take this to the right side and then get a general formula for the non-conditional distribution function of xj. That means f of xj of x is going to be, remember, this difference is on the left side. I will take this to the right side, and this one equals 1 minus qj, okay? So this can be just 1 minus qj plus this part, right? Plus qj times the conditional distribution. Always with x being greater than 0 and less or equal than the policy limit. So our first general formula is going to be zero. I'm sorry, x. Oh no, sorry, because this one was x greater than 0. No, this was okay. So it's 0 if x is negative, right? Because there are no negative values in this case. In the case of 0, we have this case, right? This one. So we will have 1 minus qj if x equals to 0, and 1 minus qj plus qj times f of xj given xj positive evaluated at xj when x is greater than 0, less or equal than tau, and then equal to 1 if x is greater than tau. Okay? So why is this formula important? Because as I mentioned before, the QJs, or where are the QJs, sorry. Where are the QJs? You say the QJs can be estimated from either own experience or market experience. So the QJs are going to be known somehow. And also we said that from contracts that have filed claims in previous years, we may estimate the conditional, right? So the QJs and this conditional distribution can be estimated from historical data from the insurance company. So look what we got. QJs everywhere, and this one that can be also estimated from historical data. So from this, we can obtain the non-conditional distribution function from XJ, because we said we want a model for XJ, right? Remember? I mean, we need an individual policy model. We said we need a discrete or mixed type random variable XJ. So we need a model for XJ. We just know that it has to be discrete or mixed type. And these are the general conditions for it, okay? But we need a model, okay? Not just the characteristics, but we need the explicit model for it. So we discussed about the claims rate and how can we estimate it. We talk about this conditional. We want the non-conditional, right? But we say, okay, but the conditional distribution of XJ, given XJ is positive, can be estimated also from historical data of the insurance company. So then we got a general formula for the non-conditional model for XJ. That was the main goal, right? And it can be calculated in terms of things that can be estimated from historical data. So this is going to happen all the time. In terms of probability, I am using very simple things, very simple concepts, right? Very, very simple probability. The important thing here is not the probability, it's the interpretation, right? To understand the concepts, where are we going to get information from, how to get the QJs, the conditional distribution, okay? So don't think that the difficult task is a probability. The probability in risk theory is quite easy. What is new for you is the concepts behind. How do we are going to apply this, in this case for the insurance business, okay? So think about these ideas, and if you have any questions before we continue tomorrow, at the beginning of the class, as I will always do, I will ask if there are questions from the previous class, okay? And also, I hope if we can spend some time discussing a little bit about the video and the article of the value of risk, that would be nice also to spend time about it, okay? And also, well, I want you to make use of your time. Our class is from 4 to 6 p.m., right? Tuesdays, Thursdays, and Fridays. But tomorrow, I have a meeting at Catlan. I have to be there. Well, I mean, 5 p.m. So I think we will have tomorrow class from 4 to 5 p.m. It's going to be a 1-hour class, okay? And I'm telling you this in advance so you can organize your time and know that we are going to end the class 1 hour before, okay? But we will have our 1-hour class at least, right? Okay. Any other final questions, comments, ideas, complaints?
Nope. Everything's good.
Good. Well, if there are no more questions, see you tomorrow. Bye bye.
See you.
See
Bye-bye.
you.
Thank you.
Bye.
Sure. Bye.